2 viewers. Wow, it's like a real stream. I think I'm gonna kill the music. Yeah, so I fixed some nasty stuff today for TOML deserializer. So I figured for some entertainment, I'll fix some easy stuff on stream. I'm really happy that I figured out my stream setup. As you can see, I have green screen. The lighting is not great yet, but hopefully it'll get better. So I'm working on the TOML of invalidation tests. So these tests are supposed to fail, and when they don't, the deserialization is supposed to fail, and if they don't fail, then we'll consider the test fails. And we've got a bunch of test fails right now. And long story short, you take a TOML file, deserialize it. You're supposed to throw an exception because something's invalid. But in some cases, we're not throwing right now. I think these are the only outstanding ones. So yeah, I'll get to them. I'm kind of interested. I kind of want to introduce what I've been fixing earlier today because it's really interesting. I know. Actually, I'm not sure if it's really interesting. It's just really hard to figure out. Maybe if anyone expressed interest, I will. But for now, I'll just try to fix these bugs. So these ones, I consider them easy because if you just look at their names, float, leading, zero, neg, you can kind of infer, okay, it's a floating number. It has a leading zero. It's probably negative, and that's invalid. Invalid why? Because float number is not supposed to start with leading zero, right? So I actually had a pick earlier, and of course there's a zero. I guess the neg implies that it's a negative test, so it's supposed to fail. I guess so upon seeing this leading zero, we're supposed to invalidate it. So this takes us to, I guess, a brief intro of how this deserializer works, like a super high level overview. You probably can see we have a data. We throw the data at this TOML table method, TOML table with data. And if you go down there, you'll see it's simply, this public method simply takes the collection of bytes. I know this can be slow, but this is a way to be compatible with foundation data. And we straight up create, well, straight up. This is not straightforward at all. We create a string from the data. Not sure if this is needed, but I think it was. Yeah, it is needed. And then we pass it. We create a parser object and call parse, right? So parser object, it do a bunch of things when you call pass, but eventually it will return your table. And it, in turn, creates a when you initialize it, creates a scanner, and it takes the scanner takes the text. So let's look at the scanner. Scanner is, if you know anything about NS scanner, is very similar, except it's hand roll. I wrote it from scratch. It's very brute force. First thing, the first thing it does, it just takes UTF-8 characters and converting to array because I don't know if this is strictly necessary, but like working with integer index is just I wouldn't say it's natural, but it's more intuitive to me personally. So that's why I did it later if needed. And then it's just perform the scanner stuff. Like you can say, pick the word. Pick a word means, take each of its characters and make sure they all are present. If that's the case, return true. Method that starts with take means it actually consumes, quote unquote, the string. And all that does is moving this cursor number forward. So you leave the things you already parsed behind and you point to the next character you're about to parse. I think there's like real guardrails for, telling you whether you have already parsed all the things in the buffer and things like that. And that leads us back to the filling test. We're parsing a key and a value from a TOML object. So take key value, maybe? Yeah, key value pair. So I guess this is still considered part of the overview. We'll take the key, and then we take away all the white spaces. We expect a line, and then we take all white spaces, and then we take the value. So let's look at take value. It's a series of tests in order. And if any test succeeds, for example, if you start with a numeric character or a plus or minus sign, then we try to parse out a number, right? And then in parse number, it returns an any because sometimes it's double, sometimes it's integer. So at some point, we're going to start taking a decimal number. I guess this is pretty much the core of the bug. So let's take a closer look. We first look for for strings like nan and inf, because those are special values defined by both TOML and IEEE 754. So if we see these guys, we just return the corresponding special values. And then we look at the first character if it's 0. Now, the reason we need it is because we need to support things like hex or octal or binary numbers, which starts with 0 and then the marker for usual suspect for prefixes for these formats. And then we kind of like if we're not looking for any of these special radix numbers, then we just move on to parse out an integer or fraction or whatever. But this is interesting because you're not supposed to have leading zeros if it's not one of these cases, and we kind of just didn't do anything. So I'm just gonna say throw an error here. We have a deserializer error, I think. TOML deserializer error, and it takes a summary where I'll say leading zero are not allowed in numbers in I guess in numbers should be clear enough, especially given the next piece of error, which is location. Cursor location. All right. So for others, we actually have this cursor location as part of it, and that will give us your column number and raw binary. I mean, raw offset in the entire string buffer. Look as the user. So I expect this to fix bug, leading zero bug. And it did not. Float leading, am I looking at the right one? Float leading zero, nag. Hold on. So if I run the test right now, leading, scanner test 42. Uh-oh, that's not good. What? Okay, so that is the cause of this issue. Interesting. In the wrong position. So it should exist here because we're just taking, for each of the valid cases, we just straight up return the value. So we should fall through, if we fall through all three of these, then we throw. All right. It's not as bad as I thought. Yep. Negative leading zero is fixed. I didn't run the other ones, but let's take a look at leading zero position positive. So this should get fixed as well. Leading zero. I just realized I was looking at the wrong one probably. So I see oh, there's plus 0.0. I see. So we kind of throw too early, where with float numbers you can say 0 point something, and then that's sort of a leading zero, I suppose. Okay. So So we should pass if the value is a throw an error. So at some point it's going to be returned as an integer, right? Integer part, or return even. So this is the point where we decide the number is a. So we're going to return int 64 from the text. Okay, so I'm going to throw that there with some other conditions. The easiest thing probably is just say say something like this, right? So we can, and again here, if has leading 0, now we have a problem. Otherwise, we, as usual. Huh. Valid integer dot TOML. Oh, 0 by itself. Interesting. And in dot count is 1, greater than 1. Nope. Has leading 0 means the first of the integer part is 0. And if the count is also 1, that means that's the only number, then that's okay. So it should be like, if it's not 1, meaning it's probably greater than 1. Should I say greater than 1? And obviously, this will pass the test, so probably this is good enough. All right. And our leading 0 test now failed again. Why would it? Leading. Oh. So the bug really has nothing to do with whether you are pretty much. Huh, okay. We can pretty much say if the integer part, if you have a leading 0 and the integer part is more than 1, then you're wrong. Because the integer part also participate as part of the float number. You'll see it's also used here. All right. These tests passed, and the old tests are passing. All right. Okay. Moving on. Float could be that. Float underscore after. Right. And the next one is underscore before point. Okay. Integer underscore after. This is invalid. Wait, is it valid in Swift? It probably is. No, it's not. No, it's not. How about one, what was the example? 1 underscore 0.2. It's not. And the previous one is 1.2 underscore. Is not valid number. I mean, oh, I should try float or double. And this one is not valid, right? Okay. Under integer underscore before, okay. Take a guess. Underscore 123, probably not valid. Great. Is there any other similar errors here? Okay. All right, the reason I'm investigating whether Swift considers these are valid or not is that I can just piggyback on Swift. So stream is very healthy. Sorry. You probably noticed before is that we take the characters from that we consider valid for the integer or the float, and then we kind of just use int 64 or doubles initializer. And here we can, and we kind of fall back on zeros, which is not great. So instead, we should take the validation or the failure of it seriously and throw an error here. TOML deserialization error, and summary is invalid characters in integer, and the location is self.cursor location. kind of do the same thing here. Okay. Uh-oh. Nil is being returned here now for whatever reason. Oh, what did we do? What did we do? So we take the integer, we convert it. This should be okay. Nothing here should have changed. Oh, double int. That's not good. Should be int 64. And this should be, that's probably it. Double. Okay. Those went away, those errors. And do we still have the underscore before, underscore after? Yes, we do. Yes, we do. Wait. Underscore integer underscore double. Oh. Int 64. One under or dunder. Okay. And underscore after did not succeed neither. I can't be. Let's see. Take number. Underscore after. I think it comes down to how this guy works. Decimal integer without sign. Underscore after. So the way this works is we collect the digits, decimal digits, and we just loop through all the decimal digits, okay? And we stop if it's not a decimal digit for underscore. Yeah, this can be simplified. These are was collecting the characters. These used to be used to return an integer, but now it's just an array of characters. So it can be simplified, really. This is risky business, but if I say if it's self is next is digit, or self.next is underscore, we just keep going until this is not true anymore. and get rid of this outer loop nonsense. So while we haven't finished the parsing and one of these is true, we keep going. So this means all the underscores will be collected. I'm a little concerned. Let's run time part by part. Scanner test. Uh-oh. Ah, yes. That's fine. 1, 2, 3. That's fine. That's healthy. Scanner test passed. Deserializer test failed. Float underscore. Float underscore. Integer underscore. This failed? How? Okay. Take number. Luckily it's not super hard. It's just one number, so we'll just use one breakpoint and look at the integer part. Integer part have 5 values. That's a bad sign. I bet. That looks fine. Does it have leasing 0? Does it? No. Okay. Int 64. Hold on. This failed. Why? It's the underscore, isn't it? If I get rid of it, okay, so it's not that great. It's not that great. Yeah, so what I did earlier is bad. Everything. Okay. 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 All right, back to the old state. So we really need to manually keep track of these underscores. So it seems like the underscore after case we're not detecting. So why does our double loop not detecting it? So the outer loop is just a way to keep the parsing going forever. The inner loop is like look for integers. If you see underscore, ignore, and continue, which will go back, restart, right? Expect a number. How about this? Everything else passed. Underscore after didn't pass. Underscore double did pass though, because previously it didn't, right? If I comment out this guy, run underscore double, it shouldn't pass, right? Okay, so that fixed that. What if I just paste this code right here? Probably need to add a guard. Float underscore after. Hold on. Hold the horse. "19 failures." Comes out. 19 failures. Fixed nothing. So let's take a look. Underscore before. I guess that's intake number. C dot at some point is being used. Okay, so I wonder what is getting parsed here. Specifically this one. it passed parse 1.2. So interesting. Okay, so what is the integer part in this case? Oh, it's of course it's gonna be 1. Yeah. Yeah, it's 1. Because underscore is being ignored. Okay, okay. So it is in take decimal, except it's like when we break, we need to make sure this doesn't happen. Right. So decimal. So before we break, we were like, if the next character is underscore. Wait, it won't be underscore. It should be like if we just ignored underscore. Or we'll just see what happens here. What does this do to this test? It doesn't fix it because underscore, we should continue. We should never exit. So when it does exit, especially for the integer part, it has just ignored a underscore. I see. So it's like if what really happens is just triggered, we go back up, and then none of the rest. Wait, this should happen. Take decimal. Wait, what? Okay, so we're in the loop. We're like, this won't happen. We'll take next, which is 1. 49, yes. Then the next number won't be a digit. So we are gonna take the underscore, which is true. So we continue, we go back up. Well, the next one won't be underscore anymore. Yeah. So that won't trigger. But we, I see. So we need to look at what's after the underscore. If it's a digit, we need to keep going. Okay, so we need another state basically. Oh, that's ugly. All right. Just saw underscore equals false. And if we see anything here, then we make self dot just. And when we do this, we're gonna make it true. And then before we exit, why am I typing self here? If just saw underscore, then we're gonna throw the same error. And does this also eliminate the need for this condition? Because if you have two consecutive underscore, you would trigger this, it will increase by 1, set this to true, continue, and the next time you're gonna go right back here. I mean, you kind of can do it this way. So when you're here, but you just saw underscore also, then you can throw this error, right? I feel comfortable with this change. Everything looks good. Yeah, we fixed those underscore after ones. Actually, we fixed all the underscore ones. Yay. Okay. Another category of errors. And it looks like they control 1, control 2. What are those? String, basic, multi, 3, 4. Is this a what? Is it a control character? And we don't like it, something? String, basic, control 2. Yeah, it's a control character. All right. We have take basic string. Let's look at how it works. So we just take until any of these true, and we deal with escape sequences. Okay, seems easy enough. ASCII control characters. Control characters. Aha. Basic strings, any code except those must be escaped. Control character 0, 0. Ah, perfect, perfect. Greater than or equal to 0 and less than or equal to 1f. Or 7f. Okay. I guess I can simplify that. Is control character we take this condition return control characters must be escaped. We are looking at this guy. Uh-oh. I didn't fix it. Darn, it broke something. Okay. Oh. Is that why? Let me make sure this definition is correct. C greater than or equal to 0 and less than equal to 1f. And 7f. This shouldn't matter. So what is it about this that triggers the problem? Try, do this, catch, let, error, print error. Co-founder and CEO. Aha, yes, yes, yes. This is a bug. This yeah. Okay. Found a bug in the old test. That's good. Fix that one. So this can go back. All right. So what it is about multi-line control? Oh, multi-line control. So the control ones are fixed. Great. Now we're back to multi-line control. So we can take a look at multi-line basic string. So we eat the 3 starting quotes. We eat a new line, however long that is. Sometimes it's 2 character long. And then we do the same thing. We stop if is control character, a control character is encountered. And then we do the same thing. If is control character $0, well, not $0, but self.next. We throw that error. Control character, this error. Fix. Yes. Perfect. Uh-oh. Multi-line string. Something is bad here. Input 1 line. Quote. Quote. Something is bad here in this. I don't even know what happened. Can't construct array with count smaller than 1. Which array? This array. Count is self-location column. Column is less than 1. Oh, he was testing this guy. So storing here is a thing that I didn't escape. Hmm. Hmm. New line and character return shouldn't be special character, is it? Wow, the stream is really healthy. Carriage return. Right here. Dang. New line. Yeah, that's a problem. That is a problem. So we need to single those out because they are okay. They're okay. They're okay. They're okay. Interesting. Form feed is bad, but character return and new line is fine. New line. Yeah, line feed is fine. 10 and 13, or rather A and D. Okay. Is control character. That's how I wrote it. Okay, these are back to passing. Oops. How long have I been going? 1 hour. Recording 1 hour. Perfect. String. Oh, wait. Literal multi-line control is fixed, right? Control. Basic multi-line control are fixed. Perfect, perfect. All right. So just rinse and repeat for literal string. Take literal string. Exact same thing. Is control character $0. If it is control blah 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 blah. So yep. Now move on to take multi-line literal string. Exactly same thing. We take and take and take and then we throw this error. All right. We have how many error? Only 4 left. Wow. Whew. Multiple dot keys. This is invalid. Oh no. It's one of these structural things. I thought I already did that off string. Okay, let's take a look at another one. End of line. This is bad. Okay. Key after array. Key after table. Yeah, there's a thing. Take a header for table or array. We should anticipate a basically as a unit. We should anticipate the end of line. Okay, that's this guy. This multi-dot key one is really concerning me because I don't know if I can solve that on string. We'll see, but we'll solve the other ones first. So level, I mean. So at some point we do have take take array header. All right. So as you can see, take array header does stop at here. Take while is white space. This shouldn't hurt anything. We have fall failure. Still fall failures. All right. Take all the white spaces after the header, and then and then we take the I forgot what the API, how the API is designed. It's like let end of line count equals self dot end of line. End of line count is -1, and we are not at the string. We throw an error, right? Throw TOML deserializer error, and the gist of it is array header should be followed by a new line. The end with line should here is clear to say unexpected characters after array header. Location self dot cursor location. This is high to fix that. All right. the beauty of line this way is you actually account for form feed and line feed. Sorry, carriage return line feed, which sucks, but it's something you have to do. So you in one step you check. You get to advance the cursor by the right amount of state, but right amount of count, as well as you know, as well as checking whether there is a line state. So -1 means there isn't end of line. So this needs to be repeated at a bunch of times, but this is for array header. Key after array should be fixed. Yeah, we have 3 failures. Run all. We still have 3 failures. All right, repeat that. Repeat all of this for take table failure header. I mean, now this guy will be fixed. Whoa. Test comments everywhere. Oh, this comment. I know what's wrong. I know what's wrong. Instead of take white space, I should take take trivia, except not take trivia. Take trivia. But I need a version that takes white space, comment. Oh, wow, wow, wow. Take trivia. Take white space and comment. Take trivia inline. On line. So now we can is new line next. Take new line. Don't do that. Everything else is fine. Now go back to take array header. Take array header instead of take white space. You take trivia online. And then you deal with new lines. Okay. How about now? Doesn't compile. Oh. Still doesn't work. Comments everywhere. There's some comment after the group header. So wouldn't take trivia online deal with this? Take trivia online. We have a starting point. We keep going until your text is a white space. Well, if it's a white space, we take the white space. If it's a hashtag, we take a comment. Oh, take a comment. Deals with end of line, isn't it? Doesn't it? That sucks. Yeah, take comment goes all the way until you go end of line. I'm a little afraid if I delete it, things will break. All hell will break loose because of this. Actually, it's not that bad. But hey, that worked. So take comment now will take everything up to the end of line instead of everything including end of line. And wherever it gets used, I guess it's also in context with new lines. Didn't break anything. All right. Take key, no end of line. Oh, what am I doing? I should do key, no end of line. Yeah, okay, this is. Maybe I should abstract this guy away because it's the same code everywhere. Take trivia till end of line. Take trivia including end of line. Maybe something like that. So I'll copy this, search for this. I forget about this. Take trivia online. This name is awkward anyways. Take trivia until end of line. So, oh, actually, hold on. Take trivia until end of line. So I don't need any of this anymore. Similarly, the other call site. Two failures, yes. And the next failure is going to be fixed with one line change. Take key value pair. Take key value pair. So we take, this is, this is tricky because take value is a big function. At some point, it may inadvertently take an of line, which would be bad. Let's see. Ooh, 10 errors. Arbitrary stuff. This one failed. Okay. This one failed because it's taking inline table, which calls take value. Right. Okay, so this is inappropriate. This is oversimplified. So when it's inline, at least we shouldn't expect things at the end of stuffs. Also, did I? Take key value pair. So this is called in a bunch of contexts. Take inline table, for example, and wait, is it only called in that one place? No, it's called in parser. I bet. So should I call dot take trivia until end of line here? Of course, with a try. Oh, 3 errors. Parse arbitrary stuff failed. Is it because of this? Take key value, key value, key value, key value. Maybe this is an invalid TOML because I actually wrote this test case myself. Okay, let's take a look at this one. Non-deck integers. Something here is bad. Which one is bad? Or is there's some problem with take trivia until end of line. Take so take until end of line. Like if you're not down, your white space or your hashtag. Otherwise, don't do anything. And it expects a new line. Does this not have a new line? This is kind of random. All right, let's catch the error. Do catch let error, print error, paste in. Let's go, readable error. Or a backtrace. Unexpected character after array header. Local test. 1, 2, 3, 4, 5, 6, 7. Column is -1. Offset 17. Oh, this error message is wrong. Huh. Unexpected character. All right, it sucks. All right, debugger time. Parser.swift. We take key value. Not here. Okay, we have a starting point. We didn't do anything. We expect end of line. What is end of line? It's -1. There's no end of line. What? Can I see you here? Key is bin1, value is whatever. I see. It's take binary integer without sign, take integer, yeah, this does. This is proactively dealing with end of line. End of line equals self.end of line if end of line is -1. If it's not end of line, and this, basically. What will break if I don't do this? Or rather, I can just don't advance, right? This will be fine. This is of the breakage. Yep, I bet those two tests that broke both involves binary numbers. Or rather, binary hex or octal numbers. Making good progress. Only one failure left. And it's one that I dread. The name is very misleading because you saw dot dot something, but it's not what that is. So it's the bug is, I mean, no, the reason this is invalid is because you can say a b equals 1, then the value of b is 1. But when you say a dot b dot c, that implies b is a dictionary and c, I mean, it's c is a key within that dictionary. That conflicts with the fact that b is already defined as 1. So let's think about how that works. Actually, before I deal with this tricky one, I'm going to check in all the fixes we have so far. Should I care about this should be good now. Okay. Okay. All right. Parser. Sorry, can't help but look at the stream. We've so far 0 frames from the network, which is remarkable. All right. So we have a key path here, A and B. What happens is we go in and insert the value with the key path. It's really just this part, this insert method. And when you insert a.b.c, at some point you'll get A and then you'll get B. So we're gonna be here. Sorry, this may not make a lot of sense, but it all makes sense in my head. Right, so we look at if the key exists. So we're looking at B here. Wait, we're looking at A here. So we if A is the dictionary and A.B is nil, we'll create B. Okay, that's fine. Or A in that case, really A.B is nil. I mean A. Well, top level dot A is nil. We created this, and then B will be inserted in this branch because when B is the only level key, the lowest level key. So when it's left, we're gonna say A dot B equals 1 here, right here. Okay, so next round we insert ABC. The value is 2, and ABC will land it here when key is A, and then self dot A will be already a dictionary, so it's this branch. Now we're gonna do the dictionary insert at BC value 2 recurse. Now keys will be BC, and we're gonna look at B. I think since we're inserting BC into A. Okay, so self.B is nil, is not nil. Self.A is will be met because B, A.B is 1, is not nil, it's not a dictionary, it's not A, it's not an array where there's a last element. So what if I throw an error here? What will break? Nothing. Nothing broke. Some Carthage garbage is in. Is this the test target? Yes. Look at this. Look at this. All test passed. Oh. Wow. The release. Sorry, just running the testing Docker real quick. I'll make sure nothing wacky happens on Linux. And then I think we're done. Then I think we're done. Docker is starting. Docker is still starting. Please, Docker. All right. $184 tests, 0 failures. 0. Actually, okay. This, if they fail, I'll fix. Otherwise, let's look at to-dos. There's a bunch of to-dos. Fairly sure I don't need to deal with this one anymore. This guy, if I delete, there will be a bunch of problems. Namely, yeah, all the errors here, parsing errors. So maybe instead of deleting it, I should make it, can I do private? Fair enough. But I should place this guy. So what is this problem? This is table value. That's okay. So we're inserting value into tables, and we already has, this is when key already, okay. Duplicate key value self key already exists. Something like that. And here, this is the new one we just did. So conflicting values key and value. Wait, in the middle of inserting. So I guess at least I can say key has previously been set as that. That's good. Good enough. No more to-dos. Wonder if anything broke. All right. Is there anything else we can do here? It's fair to say we're ready for the big game. We're going to submit our project into the README for the TOML project, the TOML spec. Do I already? We do. Wait, what is this? Also, did I fork this? Fork this guy. It's wiki, right? Official TOML wiki. Project using TOML. Implementations. Anyone edit this? Wow. Implementations. I assume this is alphabetical order, so so Swift would be here. Swift, me, link to me, I think they use the word decoder. Wow. Wiki is completely open, right? That's not just my view. Anyone can go here and look at. Okay, awesome. All right, I think I'm gonna end the stream. Thanks for watching. Have a good one.